Hello, my name is Ratisha.
And my name is Olivia, and we worked on the bacteria Xenorhabdus szentirmaii to identify novel antimicrobial compounds. Antimicrobial resistance, also known as AMR, is a global threat due to the historical overuse of antibiotics. Bacteria are becoming increasingly resistant to current antibiotics, making it more difficult to treat deadly infections. AMR is a growing problem to our health. Millions have died due to antimicrobial resistance and is predicted to surge to 10 million in 2050 if we don't address this pressing issue. So there is an urgent need to discover new antibiotics from new sources with new chemistry.
A promising new source of antibiotics is the bacteria Xenorhabdus szentirmaii, a symbiotic bacteria living inside of nematodes. Nematodes infect insects, and Xenorhabdus is released into the blood of the insect, where it releases antimicrobials. We grew the bacteria and took the cell-free supernatant. After spotting the cell-free supernatant onto plates and overlaying bacteria, we can see clearance zones, which indicate the presence of antibiotics since bacteria are unable to grow there. Then, in order to isolate the antimicrobials, we added amber-like beads to the cell-free supernatant, which binds to the antimicrobials. After a series of washing steps, we were left with partially purified antimicrobial compounds. Then we tested these compounds against antibiotic-resistant bacteria and found that they have activity against multiple pathogenic bacteria, including methicillin-resistant Staphylococcus aureus, also known as MRSA, Klebsiella pneumonia, and pathogenic E. coli.
Our next goal was to identify the genes involved in producing the antimicrobial compounds. Through genomic analysis using bioinformatic tools, we identified 17 non-ribosomal peptide synthetase genes, named as STI1 through STI17, which are involved in the production of antimicrobial compounds. Our subsequent RNA-seq analysis showed that the genes STI1, STI2, STI10, and STI17 are all upregulated when antibiotics are produced.
So we developed a novel protocol for antibiotic purification and identified an antibiotic active against multiple antibiotic-resistant bacteria.
And we identified 17 biosynthetic genes for antimicrobial compounds, and some are upregulated during the antibiotic-producing phase.
So our work is a step forward to identify new antimicrobial compounds to combat AMR.